Hello viewers. Today we are going to take up one important area which is also a part of your course, that is BME 020, that is kinematics and dynamics of mechanism. From that course we are taking an introduction part, that is a theory of machine. In this today's session we will discuss the basic elements of theory of machines. What are the different parts which you are required to know, and some basic definitions we will take up in today's lectures. First of all, we will discuss that what is the machine. When we discuss that it is a theory of machines, or we are trying to take you in the area to explain you that what is the machine. The machine is a simple device which basically converts input energy and transform it into some useful work. This is a diagram that energy is coming to a machine which is transformed into useful work. Remember the word useful. If it is not useful, the machine is not existing. So it is required that energy with the help of machine is transformed into some useful work. And another type of thing is that it consists of number of parts. It may be a single part, but it also constitutes of many parts. So basically, if we summarize this thing, that machine constitutes of many parts which takes the energy in one form and transform into some useful work. So after that we will take up a definition of theory of machines. That what is theory of machines? It is an engineering science which deals with the different type of motion, different type of forces which acts on the different parts of a machine. So it is basically a branch of engineering science which deals with the study of relative motion between the various parts of machine. This is a very generalized definition which simply says that in this subject or in this area you will visualize that how the motion between the different parts take place, and the motion of one part, how it is affecting the motion of other part, or what are the different type of forces which acts on the different parts or the bodies of the machine. If we say that this is one topic, theory of machines, but it constitutes of many sub areas. For example, these are the four basic major areas, just like kinematics, dynamics, kinetics and statics. If you see that kinematics basically deals with the motion, relative motion between the parts of a machine. It does not tell us the effect of the forces. Second part, or the second subdivision, is the dynamics. Dynamics takes care of the forces. It is a branch of a TOM which deals with the forces and their effects while acting on the machine parts in the motion. In the dynamics, we normally study the effect of forces, and due to the effect of forces, what are the different type of motions in the machine parts. Third division is the kinetics. In kinetics, we study the combined effect of mass and the inertia forces on the parts of a machine parts. So if you see the definition, that it is the branch of TOM which deals with the inertia forces which arises from the combined effect of mass and the motion of a machine part. As you know that inertia can be static inertia, it can be dynamic inertia. Static inertia is due to the position of a body or a part of a machine it is in the rest. Dynamic inertia is a type of inertia which is due to the motion of a body. So this branch, kinetics, takes care of both type of inertia, and it sees the combined effect of static as well as dynamic inertia on the various parts of machines and the motion of the machine parts. Last area is called the statics. As the name implies, that it is the area when we try to analyze when the bodies are at the rest. Statics. So if you see the slide, that it is the branch of TOM which deals with the forces and their effects while the machine parts at rest. The mass of the parts is assumed to be negligible. Here it is a very important part, that in statics we are not considering the mass of the machine parts. We consider it as a negligible, and without considering the mass, we try to analyze the effect of forces acting on the different parts of the machine. Now we see that what are the different constitutes of the machine, or how machine is constituted. Basically, if you, as earlier I have defined, that machine constitutes of many parts. Now these small parts, they are assembled for a machine, and machine should be designed in such a way that the relative motion between the parts of the machine should be well defined. Means it should carry over the effect of forces to have the desired useful work. In the machine, the most important part or the most elementary part is called the kinematic link or the element. As we see in the slide, that each part of a machine which moves relative to some other part is known as kinematic link or the element. This may be binary link, ternary link, quaternary link. So here the link is elementary part which just it carries the forces as well as the motion from one part to another part. And there are other type of definition also of the kinematic link which we are not considering at this moment. We simply say that kinematic link or the element is the basic part of the machine which is resistant, rigid, and it is, carries the or transform the one form of motion to another form of motion, or it carries the forces, effect of forces from one end to another end. Another important point here is that it is not necessary that link is a one part. It may constitute of one or more than one part. But the condition here is that there should not be any significant movement between the parts of a link. That means a link may constitute of many parts, but there should not be any movement between the parts of a link. Then only it is called a link or kinematic link. As you see in the slide, that it has two links, two parts. Similarly, it has 1, 2 and 3 parts, but the relative motion between these two links are fixed. Similarly, the relative motion is also not there, so they can be considered as one link. And here it is called now kinematic link, since there is no relative motion and they are rigid and the resistant. Now comes the picture that what are the main examples of this type of link. If you consider a reciprocating engine, in which we have a steam engine, we have a crankshaft, we have a connecting rod and a reciprocating piston. or the simple piston. In that we will see that how the different parts constitute the different links. Let us see the slide. That in a steam engine, piston and the crosshead constitute a one link. Crosshead, as you remember, it is a type which guides the piston in the cylinder. Connecting rod with big and small end, brushes, caps and bolts constitutes the second end. Crankshaft, which rotates along with the flywheel, is a third link, while cylinder, bed plate and the main bearing act as a fourth link. So in this way you see that this reciprocating engine or the steam engine constitutes the four links. First is between the piston and the crosshead, second is between the crankshaft, third is the connecting rod, and the fourth one is your cylinder and bed plates, etc. So in this way this steam engine is a four link mechanism. Now we will see that how we can classify these links. The link can be classified on the basis of the joining capacity of the link. The link can join only one link, link can join two link more, link can join three link can join four link. So on this basis we can classify the links. As you see that this link is a singular link, since it is only connected to a single link. So that is why it is called the singular link. Second link is called the binary link. Binary link is a link which is connected to two other links. Just see, two links can be connected from this end and from this end. So it is called the binary link. Similarly, if you see that third link, if a link can connect three links, it can be ternary link. If it can connect the four links, it is the quaternary link. If you see the figure, that this link has the 3 points from where we can connect the different links. Similarly, in the quaternary link we have 4 links where the other type of 4 links can be connected. Now we will define that what is the rigid body and what is the resistant body. If you see that in theory of machines or in any science, when we study a part or a body, we treat them as a resistant body or the rigid body. So there is a purpose, because we do not want, or we are unable to analyze the motion or the minute motion between the parts. So we define for our analysis purpose that this body is a rigid body or this is a resistant body. If we see that the rigid body means that if the force is applied, then this body should act on the direction of the force, but the internal parts or the internal parts of this body should not have any relative motion. So then it is called the rigid body. And the resistant body is that type of a body which is a rigid for our practical purposes. If you see the slide, that this is a simple body, any sketch of the body, and here A and B is the 2 points which we have taken, and suppose we apply a force from this direction and it is moving, either in it will rotate or it will go in a linear motion, but the distance between these 2 points should not change. Then it is called the rigid body, and it can be considered as a resistant body if it is rigid or the displacement between these 2 points is negligible. Then we treat it as a resistant body. So in our all examples we will consider the parts as the resistant part or the parts with the resistant bodies. Any link need not to be rigid body, but it must be resistant body. A body is said to be resistant if it is capable of transmitting the required force with negligible deformation. What does it mean? That a link need not to be rigid, but if the displacement between the 2 points is negligible and it is capable of transforming the force, then we can consider it as a resistant body, which can be considered as equivalent to the rigid body for the calculation purpose or for the analysis purpose. Now a link, if you see the slide, should have two characteristics. First, it should have the relative motion and it must be resistant body. Suppose we take the example of a cam. The cam has just like see that 1, 2 and 3 links. So this motion is translated, or there is a relative motion between the follower and the cam and this body, but there is no deformation in the follower or in the cam. So it is a link. Similarly, your slider crank mechanism, which is an example of your steam engine, it is again translating the motion, and there is a relative motion between connecting rod, crankshaft and the connecting rod and the piston, but all are resistant bodies, so they can be considered as a link. This is a simple example of a 4 bar. These are the 2 fixed links, and 1, 2, 3, these are the movable links, so it is a 4 bar link. This only gives you an example that how the links is combined to form a mechanism. Here is examples of different links in your practical. For example, your hydraulic press, jacks and brakes, where the links are resistant to the compressive. Similarly, chain, belt and ropes are also tried as a link, and they are resistant to tensile forces. So you see that here there are 2 types of forces. One is the compressive forces and another is the tensile forces, and the links should be capable of bearing such type of load, either compressive load or the tensile load, depending upon the situation. We have given example of hydraulic press, so there is a compressive force, so the links there should be capable of transforming or resistant to the compressive force. Similarly, your chain belts, which are resistant to tensile forces, they are also treated as a link. Now we will have a very basic thing, that there is a one component called the structure, and second called is the machine or the mechanism. So what is the basic difference? Such like a building is a structure, while your any lathe machine, a lathe or any CNC, it is a machine. So what is the difference between the structure and the machine? I have written some small points. You can see from the slide that basically if you define the structure is basically what? It is an assemblage of different types of linkages, but it is not capable of translating the motion from one end to another end. Just like building, yes, it can translate, but it is not made for the purpose of translating or transforming the motion from one end to another end. But machine is definitely made only for this purpose, that it translates the motion or it transforms the one form of motion into the another form of motion. So the difference between the machine and the structure, if you see the slide, that the parts of a machine move relative to one another, whereas the members of a structure do not move related to one another. As you have an example of a building, that it has the different parts, the body has the different parts, but there is no relative motion between the structure of the bodies of the structure. Another difference is that the machine transforms the available energy into useful work, whereas structure there is no energy is transformed. Another difference is the link of the machine may transmit both power and the motion, while the member of the structure only transmit the forces, means it resists the transform or it bears the either compressive force or the tensile forces. Now we see that we have studied the basic element, that is the link. Now when we are moving towards the different type of a motion, here we will define that there are three types of motion between the machine parts. First is called the completely constant motion, second is called the successfully constant motion, and third one is unsuccessfully or incomplete constant motion. We will see from the slide that how they will define. In the completely constant motion, if you see the slide, that sometimes the motion between a pair is limited to a definite direction, irrespective of the direction of the force applied. Such motion is said to be completely constant motion. Here we would like to define this thing, that in a completely constant motion, the motion is applied in one direction, but it is unable to fix the motion of the different parts. So the part moves according to their mechanism. So that type of motion is called the completely constant motion. Another type of motion is called the incompletely constant motion. Here the motion between the pair and can take place more than one direction. Such motion is called the incompletely constant motion. In case of completely constant motion, the motion is only in one direction but irrespective of the force direction. But in case of incompletely constant motion, the force is applied in one direction, but the parts can move irrespective of any direction, so it is called the incompletely constant motion. Third type of motion is called the successfully constant motion. If you see the slide, that sometimes the connection between the elements forming a pair is such that the constant motion is not completed by itself but by some other means. Such a motion is called the successfully constant motion. Now if we have several examples where we need the successfully constant motion, where we have to apply certain mechanism so that the part of the bodies or the machine should move in a particular or the guided direction or the directed direction, so that we get the desired or the useful work from that machine. Such type of motion is called the successfully constant motion. After defining these all three types of machine, we come to the very basic type of things, that kinematics of the motion. Here the motion can define as a plane motion, rectilinear motion, or the curvilinear motion. The plane motion, as it's already self-explanatory, that plane motion means all the parts are moving in a one plane, then it is called the plane motion or the planary motion. Here we have one example. This is a link of this thing, and the motion of all the links are in one plane or the parallel plane. So such type of motion is called the plane motion. But similarly, your rectilinear motion and the curvilinear motion, here we have a combined type of a motion, Just like see this wheel is rotating, so wheel is rotating and as well as it is moving. So it is a curvilinear motion as well as rectilinear motion, or it is a translation as well as rotation if it is not slipping. Similarly, if you take the example of these two pistons and this rod, so this rod is oscillating or having the rotation motion, while these two pistons have the translation motion. Now we will define that the mechanism. What is the mechanism? How the mechanism is constituted? Basically, this your subject deals with the kinematics and the dynamics of the mechanism, and its whole constitute the theory of machines. So first we will see that what is the mechanism. You see the slide that mechanism can be defined as a closed or the kinematic chain in which one link is fixed, or the kinematic chain which forms the mechanism should have the constant motion. So here the mechanism means it constitutes of several links. It may be 3, 4, 5, but the one link should be fixed. Second thing, that mechanism should have the constant motion. It should not like that it should have free motion, but it should have a constant motion. Means when the force is applied, there must be some motion in the linkages of the mechanism. Then only we can say that this is a mechanism. And another thing which you have noticed in this definition, the kinematic chain. We will come to why we will define the kinematic chain, or how we will define the kinematic chain, or what is the difference between a simple chain and the kinematic chain. Now we see the slide that in the mechanism define there is a definite motion of any link which produces the unique motion of all other links. The relative motion of any link uniquely define the relative position of any point or any other link. This means that a mechanism should always define the motion of one link with respect to the motion of another link. Another thing is that the relative motion of a link, if it is taking, suppose we take the example of a reciprocating engine, then the motion of connecting rod should be defined by the relative motion of the crankshaft. Similarly, the relative motion of connecting rod should define the motion of the piston. So these are the important points which should be considered while defining the mechanism. Now we will see that what is the planar mechanism. Here you see, as we have said, that 3 links are the basic links in any mechanism. This is a 4-bar mechanism. Why it is called the planar mechanism, as I have told you, that if the motion is taking place in a one plane, then we say that it is a planar mechanism. So basic we need the 3 links for the kinematic chain, and these are called the kinematic pair. Just like the joining point between these 2 links, for example 3 and 4, this point is called the kinematic pair. So if you see this, take the example of this link or the chain, and if we just fix, because as we have said that for making a mechanism the one link should be fixed. If we fix this link, we do not have any relative motion between link 3, 2 and 1. So it cannot be considered, because that is the basic definition of the mechanism. That first thing is that the mechanism should be, in the mechanism there should be one link which is to be fixed, and there should be a relative motion between the links. So when we are seeing, we are analyzing the three link chain or mechanism, and when we are fixing any one of the link, then there is no relative motion between the other two links. So the 3-bar mechanism cannot be considered as a mechanism. It can be considered as a simple chain, but it cannot be considered as a mechanism. So if we see another 4-bar mechanism, and if we fix any one link, then we will find that there is a relative motion between the different links. If we see the slide, that if you see the slide, then just we have fixed one link, link 1, and link this is link 2, this is link 3, this is link 4, and this link 4 is in the rotation direction, and it has the relative motion between 2, 3 and 4. Therefore this 4-bar chain can be considered as a basic mechanism instead of 3-bar chain. Therefore the simplest mechanism is a 4-bar. So why we are telling all these things? Because for analyzing the different machines, for analyzing the different mechanism, just like slider bar mechanism or quick return mechanism, we need the basic fundamentals of the mechanism. So we have to understand, once we understand the motion or the effect of forces which acts on the 4-bar mechanism, we can easily understand the effect of forces and the motion in the complicated or the complex mechanism. Now we will take the one example of a reciprocating engine, and we will see that how this is transformed, or it can be called as a 4-bar mechanism. So just see that here we have fixed the link 1. This is link 1. So link 1 is fixed. Link 2 is rotate, which is a crankshaft, while 3 is oscillate, it is a connecting rod, and the link 4 is has the reciprocating motion, which is a piston. So this forms you the 4-bar mechanism. So it is not like that you have always a very simple structure like 4-bar, having the 3 mechanism in this direction and 1 is fixed. We have a very complicated mechanism which exists in our daily routine life, and since it's essential to see the effect of forces on these bodies, so that we can analyze the effect of forces so that it can be modified for the improvement purpose. Now we see that the slide, that in this it is an example of an internal combustion engine which converts the reciprocating motion of the piston into the rotary motion of the crank. Just see that this is in the rotation, and this rotation of the crankshaft is converted into the reciprocating motion of the piston. Or if we say in other way round, that in your simple 2-wheeler or any 4-wheeler mechanism, we are getting the power from here, and this reciprocating engine is transformed in the rotatory motion of the wheels, and we get the movement of the our 2-wheelers or the 4-wheelers. After this, we will see that since the two links join with each other, and the joining point is called the pair. So we will see that what is the definition of a pair, and when this pair is called the kinematic pair. If we see the slide, that kinematic pair is formed when two links or the elements of a machine are in contact with each other, provided there is a relative motion between them which is completely or successfully constant motion, or it is called the fixed type. Then we say that it is a kinematic pair. We can divide or we can classify the kinematic pair in the three categories. First is called the lower pair, second one is higher pair, and the third one is the wrapping pair. Basically, the type of contact is the basic criteria for classifying the kinematic pair. Now we will see that what is the lower pair first. Lower pair. In the lower pair we have a contact, surface contact between the two links. If we see the slide, we will simply see the definition that when the connection between the two elements is through the area of contact or there is a surface contact between the two links, then the pair is called the lower pair. Example here is the motion of slider in the cylinder or the motion of crank pin and the connecting rod at the big end. Here we have a very good example of a lower pair. It is called the revolute pair. You see that this is a simple and it is in the rotation. So this motion is constant, but this link, two links in between, and this type of a pair is called the revolute pair. This pair, just see that this pair allows only relative motion between element 1 and element 2. There is relative motion because it has a rotation motion, and it is expressed in terms of coordinate theta. Therefore, we can say that it is only 1 degree of freedom. Another type of pair is called the prismatic pair or the sliding pair. Again you see that this is element number 1, this is element number 2, and the contact between these two element is a surface contact. So this is a lower pair. Here again it can be expressed between the coordinate s, the movement, the rectilinear motion or the linear motion between these two pair. So again it has a only 1 degree of freedom. Third type of pair is called the screw pair. You just see that we have several examples in our daily life. Here this is in the rotation and these are the fixed. As you see that we have a bolt and nut or any type of screw, jack, we have a such type of mechanism, and here are the two motions relative to each other. One motion is upward and another motion is downward. So in this the screw pair has again 1 degree of freedom because the relative motion between 1 and 2 can be expressed either by the theta angle or by the displacement s, and this is the relationship that delta theta by 2 pi is equal to delta s by L, where L is the lead screw. Lead screw is the distance between the two teeth when we are moving it is rotation is only 1. Then it is called the lead for a screw. Another type of pair is called the cylindrical pair. If you see the slide, that here this is in the rotation, this is your fixed, this is element number 2 and this is element number 1. So again there is a relative motion between these two pair and the contact is a surface contact between these two. So we have a contact surface and hence it is a lower pair. This relative motion between these two pair is expressed again in terms of theta and s, but since they are not related with each other, here the degree of freedom is 2. Another type of pair is called the spherical pair. It is also called the ball and socket joint. You see that this is between this and this link and this. Again this is a surface contact, so again it is a lower pair and having the 3 coordinates to explain the motion. So this is a 3 degree of freedom because 3 quantities are required to define the motion. Another type of pair is called the planar pair. If you see the slide, it is basically a plane motion between the these two elements. This is element number 2 and this is element number 1. This may have a rotation or whatever linear motion, just like if you have a shaper or planer machine, you will see this type of a motion in that type of motion. Again, it is a 3 degree of freedom between this element 1 and element 2. After discussing the lower pair, we will come to the higher pair, where the contact between the two elements is a line contact or the point contact. In case of lower pair, we have a surface contact, while in case of higher pair, we have either line contact or higher pair. Let us see how we will define the higher pair. If you see the slide, that a higher pair is a kinematic pair in which the connection between the two elements is only a point or the line contact. And here we have example of a higher pair. This is your cam mechanism, and between the cam and the follower there is a point contact, and only basis of this point contact it gets the motion from this cam to the follower and follower to the remaining mechanism. So such type of pair is called the higher pair. And you see that the pair between these two is through a line, and examples of such pair is called the bearing pairs, roller pairs, gears, etc. Third type of pair is called the wrapping pair, which is existing between the belts and the chains. Here is an example of a belt. These are the pulleys, and in between these two pulleys the belts are transforming the motion from one end to another end, and such type of pair is called the wrapping pair. Now we will see that what is the difference between the machine and the mechanism. Machine is basically a type of a mechanism which is used for transforming the motion or the energy one form into the another form, and we get the useful work or the energy. So in today's lecture we have discussed that what are the basic elements of the mechanism. The element or the link which translate or transform the motion from one end to another end is called the link, and the basic requirement of a link is that it should be rigid or the resistant. The chain or the basic chain is a mechanism which translate the motion from one end to another end and having the relative motion between the links. So we have also seen that the basic mechanism is a 4-bar mechanism, and 3-bar mechanism cannot be considered as a basic mechanism, because the basic requirement is that we have to fix one link, and one link is fixed, the 3-bar mechanism cannot translate the motion. So therefore your 4-bar mechanism can be treated as a basic mechanism. After that we have also studied the different type of pairs, that is the lower pair, higher pair and the wrapping pair. Thank you.